Neptune, the mysterious blue planet, introduction, far beyond the warmth of our sun. Past the rocky worlds, the gas giants, and even Uranus, lies a mysterious, icy blue world. A planet that marks the true outer edge of our solar system's known planets. Neptune is often called the hidden giant. It's invisible to the naked eye, and unlike the other planets, it wasn't discovered by simply looking up at the night sky. Instead, it was found through mathematics predicted before it was ever seen. That alone makes it one of the most fascinating planets in astronomy. In this video, we're going to explore Neptune in depth, from its discovery in the 1800s to its violent storms that make it the windiest planet in the solar system. We'll uncover its strange moons, its faint rings, and even the possibility of diamonds raining deep inside its atmosphere for the next 45 minutes. Let's journey to a world over 4.5 billion kilometers away, where sunlight takes more than 4 hours to arrive, and where mysteries of the outer solar system still wait to be solved. Welcome to Neptune, the planet of extremes, beauty, and cosmic secrets. Basic facts and position in the solar system. Now that we've set the stage, let's begin with some essential facts about Neptune and where it sits in our solar system. Neptune is the 8th planet from the Sun, making it the most distant major planet we know. It orbits at an average distance of about 4.5 billion kilometers, or 30 times farther than Earth. To put that into perspective, if Earth were the size of a marble, Neptune would be about 30 marbles away. That's an incredibly lonely orbit on the edge of our solar family. Because of this great distance, Neptune takes an astonishing 165 Earth years to complete a single orbit around the Sun. Imagine, since its discovery in 1846, Neptune has only just recently completed its very first orbit in modern history. In terms of size, Neptune has a diameter of nearly 49,000 kilometers. That's about 4 times wider than Earth. It's massive, with a mass 17 times greater than our planet. Yet it's still smaller than its neighbor Uranus. The planet is a frigid world, with average temperatures hovering around -214 degrees Celsius. Even though it's so cold and distant, Neptune has one of the most dynamic atmospheres in the solar system, filled with violent storms and supersonic winds. When you look at Neptune through a telescope, what strikes you immediately is its rich blue color. This stunning hue comes from methane in its atmosphere, which absorbs red light and reflects back blue. It's this unique shade that makes Neptune one of the most beautiful planets to observe, and in the grand layout of our solar system, Neptune stands as the final major planet, right before the icy realm of the Kuiper Belt, home to Pluto and countless other frozen worlds. In many ways, Neptune is a gatekeeper to the mysterious frontier beyond. Discovery and history. Unlike the other planets, Neptune wasn't spotted by chance. You can't simply look up at the night sky and see it with your naked eye. In fact, Neptune is so distant and faint that for most of human history, no one even knew it existed. The story of its discovery is one of the greatest achievements in astronomy. In the early 1800s, astronomers noticed something strange about Uranus, the 7th planet. Its orbit didn't quite match the predictions of Newton's laws. It seemed to be tugged slightly, as if by an unseen hand. Two mathematicians, working independently, Urbain Leverrier in France and John Couch Adams in England, calculated that the irregular motion of Uranus must be caused by another, unknown planet farther away. Using only mathematics and the laws of gravity, they predicted where this mysterious planet should be found. On September 23, 1846, German astronomer Johann Galle, guided by Leverrier's calculations, pointed his telescope at the predicted location, and there it was, a small, blue disk against the backdrop of stars. Neptune had been found, not by accident, but by mathematics. This was the first time in history a planet had been discovered in this way. The planet was soon named Neptune, after the Roman god of the Gian, appropriate choice for a world wrapped in deep blue tones. This discovery wasn't just about finding a new planet. It was a triumph for science itself, proving the power of mathematics and physics to reveal worlds hidden beyond our sight. Neptune became a symbol of human curiosity, reaching further asterisk. Structure and composition beneath Neptune's stunning blue exterior lies a world of extreme conditions and mysterious layers. Like Uranus, Neptune is classified as an ice giant, different from the gas giants, Jupiter and Saturn. So, what exactly makes Neptune an ice giant? Let's peel back its layers. At the very top is its atmosphere, made mostly of hydrogen and helium, with traces of methane. That methane is what gives Neptune its famous blue color. But unlike the thick, stable layers of Jupiter, Neptune's atmosphere is wild, constantly shifting with storms and winds. Beneath the atmosphere is a deep mantle, made of a strange mix of water, ammonia, and methane ices. This isn't ice like we know on Earth. Here, under crushing pressure and searing heat, these ices behave more like a thick, hot, slushy fluid. Some scientists even believe that within this mantle, carbon atoms could compress into diamonds, literally raining down through the planet's interior. Imagine an endless storm of falling diamonds in the darkness. At the very center lies Neptune's core, small, rocky, and metallic sphere about the size of Earth. Temperatures here can soar to 5,000 degrees Celsius, hotter than the surface of the sun, even though the planet itself is freezing on the outside. This internal heat is what powers Neptune's wild weather, driving storms that rage across its skies. Compared to Uranus, Neptune is actually denser, meaning it has more mass packed into a slightly smaller size. This suggests that Neptune may have a thicker, more concentrated interior, giving it a stronger gravitational pull than Uranus. In short, Neptune is a planet of layers, a stormy atmosphere, a mysterious icy mantle, and a fiery hot core. It's a world of contradictions, cold on the outside, blazing within. And it's this hidden structure that fuels some of the most extreme conditions in our solar system. Asterisk. Atmosphere and weather. If there's one thing that makes Neptune stand out from the other planets, it's the incredible violence of its atmosphere. Despite being so far from the sun, Neptune is the windiest planet in the entire solar system. Winds here can reach speeds of 2,100 kilometers per hour, faster than the speed of sound and stronger than the most powerful hurricanes on Earth. Imagine standing in a storm where the winds move faster than a fighter jet. That's Neptune's everyday weather. But winds are only part of the story. Neptune is also home to massive storms that dwarf anything on Earth. The most famous of these was spotted by Voyager 2 in 1989, the Great Dark Spot. This storm was roughly the size of Earth itself, swirling with high-speed winds and violent activity. Unlike Jupiter's Great Red Spot, which has lasted for centuries, Neptune's storms are more temporary. The Great Dark Spot vanished within just a few years, only to be replaced by new storms forming elsewhere. These shifting storms show that Neptune's atmosphere is dynamic and constantly changing. Clouds of methane ice crystals form high in the atmosphere, creating bright white streaks across the planet's blue surface. To observers, these clouds look almost like high-altitude, cirrus clouds on Earth, except they stretch thousands of kilometers across. And then there's the temperature mystery. Even though Neptune receives less sunlight than any other planet, it actually radiates more than twice the heat it gets from the sun. This means Neptune has an internal heat source, likely left over from its formation, that powers its storms and fierce winds. From the outside, Neptune may look like a calm, blue marble, but up close, it's a raging world of supersonic winds, giant storms, and icy clouds. A planet where the weather is not only extreme, but ever-changing. Asterisk. Magnetic field and radiation. As if Neptune's storms weren't strange enough, the planet's magnetic field adds another layer of mystery. On Earth, our magnetic field is neatly aligned, running almost directly along our planet's rotation axis. But Neptune's field, it's tilted a dramatic 47 degrees from its axis of rotation. Even stranger, it doesn't pass through the planet's center at all. It's offset by about a third of Neptune's radius. This creates a wildly uneven magnetic environment. In some regions, the field is much stronger than expected, while in others it's weaker. Imagine carrying a magnet where the poles weren't neatly at the top and bottom, but oddly off to the side. That's Neptune. Scientists believe this strange field comes from the planet's unique interior structure. Instead of being generated in a metallic core like Earth's, Neptune's magnetic field is thought to arise within its slushy mantle of water, ammonia, and methane. The complex movement of these electrically conductive fluids produces a magnetic field that's tilted and lopsided. The result is an unusual system of auroras, curtains of light like the northern and southern lights on Earth. But on Neptune, these auroras don't sit neatly at the poles. They appear in odd, shifting locations across the planet, following its strange magnetic geometry. As for radiation, Neptune doesn't bombard space with as much intense radiation as Jupiter does, but its tilted field still creates a complex environment for its moons and faint rings. Any future spacecraft visiting Neptune will need to navigate this chaotic magnetic bubble carefully. In short, Neptune's magnetic field is anything but ordinary. It's tilted, off-centered, and unpredictable, just like the planet itself. Asterisk moons of Neptune. Around Neptune is a family of 14 known moons, each with its own story. But among them, one stands out as truly extraordinary: Triton. Triton is Neptune's largest moon, and it immediately grabs attention because of its retrograde orbit. It moves in the opposite direction of Neptune's rotation. This tells us something important. Triton didn't form alongside Neptune. Instead, it was likely a captured object from the Kuiper Belt, a region of icy worlds at the edge of the solar system. Neptune's gravity pulled Triton in long ago, making it a permanent but unusual companion. Triton is about 2,700 kilometers wide, roughly the size of our own moon, and it's one of the coldest worlds ever measured, with surface temperatures around -235 degrees Celsius. Yet, despite this frigid environment, Triton is alive with activity. When Voyager 2 flew past in 1989, it discovered active geysers erupting from Triton's surface, spewing nitrogen gas high into its thin atmosphere. This was a stunning discovery. Geysers on a frozen world so far from the sun. It showed that Triton is not a dead, icy rock, but a dynamic world with internal heat, possibly from tidal forces created by its capture. Triton's surface is covered in strange terrains, frozen plains, ridges, and smooth areas that look relatively young, suggesting ongoing geological processes. Beneath its icy crust, scientists believe there may even be a subsurface ocean, raising the possibility, however slim, of habitability. But Triton's future is grim. Because of its retrograde orbit, gravitational forces are slowly pulling it closer to Neptune. In the distant future, Triton may either shatter into pieces, forming a spectacular ring system, or crash into Neptune itself. Beyond Triton, Neptune's other moons each tell smaller stories. Nereid, with its highly eccentric orbit; Proteus, oddly shaped and massive for a non-spherical moon; and the tiny hippocamp discovered only in 2013, showing us we're still learning about Neptune's system. Together, these moons form a miniature world of their own. But Triton, with its captured origin and strange activity, remains the jewel of Neptune's kingdom, a world as mysterious as the planet it orbits. Asterisk. Neptune's rings. When we think of planetary rings, Saturn usually comes to mind with its bright, majestic bands, but Neptune, too, has its own system of rings, though they are far fainter and much harder to see. Neptune has 5 main rings, named Gaul, Leveria, Lassell, Arago, and Adams, after astronomers who played key roles in its discovery and study. Unlike Saturn's shining rings, Neptune's are dark and dusty. Made mostly of tiny rock particles mixed with organic compounds, these materials give the rings a reddish or brownish hue, making them almost invisible from Earth without powerful telescopes. What makes Neptune's rings especially fascinating are the ring arcs. Instead of forming smooth, continuous bands, some parts of Neptune's rings are clumped into bright arcs or segments. For years, scientists struggled to understand why these arcs didn't simply spread out evenly along the orbit. Today, the leading theory is that the gravity of Neptune's nearby moons, especially Galatea, helps shepherd and stabilize these arcs, preventing them from dispersing. It's a delicate cosmic dance between rings and moons. Although faint, Neptune's rings are important because they give us clues about the planet's history and the countless collisions of small icy bodies around it. They may be relatively young, formed by shattered moons or comets that Neptune's gravity tore apart, so while Neptune's rings may not be as dazzling as Saturn's, they remain a mysterious and hauntingly beautiful feature, a reminder that even at the edge of the solar system, planets are still sculpting and reshaping their surroundings. Exploration of Neptune. Despite its beauty and mysteries, Neptune remains one of the least explored planets in our solar system. In fact, only one spacecraft has ever visited it, Voyager 2. Back in 1989, Voyager 2's flyby was a turning point in our understanding of Neptune. As it swept past the planet, the spacecraft revealed Neptune's deep blue atmosphere, its raging great dark spot, and the fastest winds ever recorded in the solar system. It also captured breathtaking images of Neptune's faint rings and discovered geysers erupting from its moon Triton, an astonishing find that showed even icy worlds can be active. But since Voyager 2, no spacecraft has returned. For more than 3 decades, everything we know about Neptune has come from ground-based telescopes and the Hubble Space Telescope, which occasionally captures images of storms forming and disappearing on the planet. More recently, the James Webb Space Telescope has begun studying Neptune in infrared light, offering new insights into its atmosphere and rings. Still, many mysteries remain unsolved. Why is Neptune so much more active than Uranus? What drives its intense internal heat? And what secrets lie beneath Triton's icy crust? Because of these questions, scientists have proposed several future missions. One of the most exciting ideas is called Triton, a NASA mission concept designed to fly by Neptune and study Triton in detail. Triton could confirm whether Triton has a subsurface ocean and investigate its mysterious geysers. Other proposals suggest orbiters that could study Neptune for years, much like Juno has done at Jupiter. But these missions face challenges. Neptune is so far away that even a direct journey would take more than 12 years. Using today's technology, the cost and complexity are enormous. Still, many scientists argue that Neptune is worth it because it's not just another planet. It's a window into the outer solar system, and perhaps a key to understanding the thousands of ice giant exoplanets now being discovered around other stars. For now, Neptune remains a world glimpsed only briefly, waiting patiently for humanity's return. Neptune's role in the solar system. Neptune may seem like a lonely giant on the edge of the solar system, but in reality, its influence stretches far beyond its orbit. One of Neptune's most important roles is as a gravitational sculptor. Its powerful gravity helps shape the orbits of countless icy objects in the Kuiper Belt, a vast region of frozen worlds, and comets that lies just beyond Neptune. Perhaps the most famous example is Pluto. Pluto's orbit is locked in a 2-2-3 resonance with Neptune. This means that for every 3 times Neptune orbits the Sun, Pluto orbits twice. Because of this resonance, Pluto never collides with Neptune, even though their paths cross in space. Neptune acts almost like a cosmic traffic controller, keeping Pluto and other Kuiper belt objects in stable orbits. Neptune's gravity also influences the paths of comets. Many of the long-period comets that eventually enter the inner solar system are nudged by Neptune's pull, sending them on journeys that can last thousands of years, beyond its gravitational role. Neptune is also important scientifically. Ice giants like Neptune are now thought to be among the most common types of planets in the galaxy. By studying Neptune, we're not just learning about our own solar system, we're learning about the kinds of worlds that may be orbiting other stars across the Milky Way. In short, Neptune is not just an isolated planet at the edge of our system. It's a guardian of the outer solar system, a shaper of orbits, and a cosmic key to unlocking the mysteries of distant exoplanets. Neptune in mythology and culture long before telescopes revealed Neptune's existence. Ancient cultures looked to the seas and skies with awe when the new planet was discovered in 1846. Astronomers chose a name that reflected both its appearance and its mystery, the Roman god of the sea. In mythology, Neptune was known as the powerful ruler of oceans, wielding a trident and commanding storms and waves. This imagery fits the planet perfectly, a deep blue world, far away, with storms more violent than any on Earth. The name also connects Neptune to its planetary siblings Jupiter, Saturn, and Mars, all named after Roman gods. In astrology, Neptune is often associated with dreams, illusions, and inspiration. Astrologers see it as the planet of imagination, mystery, and hidden truths, qualities that mirror its invisible presence. In the night sky and its unpredictable weather, Neptune has also appeared in literature, music, and art. The composer Gustav Holst famously included it in his orchestral suite The Planets, calling Neptune the mystic, evoking feelings of the unknown. Writers and poets often use Neptune as a symbol of distance, mystery, or unreachable beauty. Even in modern culture, Neptune continues to inspire. From science fiction stories about space exploration to visual art that captures its glowing blue hue, Neptune is more than a planet. It's a symbol of the vast unknown, the frontier just beyond our grasp. **** Fun and interesting facts. Before we wrap up, let's take a moment to enjoy some of the most fascinating and unusual facts about Neptune, little details that make this planet truly unforgettable. First, Neptune gives off more than twice the heat it receives from the Sun. Even though it's the farthest major planet, it glows with internal energy, keeping its atmosphere alive with storms. A day on Neptune is surprisingly short, just 16 hours long. Despite being so large, the planet spins rapidly, giving it quick days and nights. Neptune's winds are the fastest in the solar system, reaching up to 2,100 kilometers per hour. That's stronger than any hurricane Earth could ever produce. Deep inside Neptune, scientists believe conditions may be so extreme that carbon atoms compress into diamonds, creating diamond rain that falls through the planet's icy mantle. A glittering storm beyond imagination. Neptune was the first planet found through mathematics rather than direct observation. Its discovery was a triumph of science, showing that we could uncover hidden worlds by calculation alone. And here's a fun orbital fact. Since Neptune takes 165 years to orbit the Sun, it only completed its very first full orbit since discovery in 2011. For most of human history, it hadn't even made a single lap around the Sun. These fascinating details remind us that Neptune is not only beautiful, but also a planet full of surprises, an extreme world where science meets imagination. Ending and future. As we reach the end of our journey to Neptune, it becomes clear that this planet is more than just a distant blue world. It's a place of contrasts and mystery, storms that rage faster than sound, a deep interior that may sparkle with diamond rain, moons like Triton that defy expectations, and rings that whisper of shattered worlds. Neptune reminds us how much there is still to discover. Despite its size and beauty, we've only visited it once, over 30 years ago. The mysteries of its heat, its magnetic field, and its captured moon remain unsolved, waiting for the next generation of explorers. Looking ahead, missions like NASA's proposed Triton, or even future orbiters, could unlock Neptune's secrets and bring us face to face with the last unexplored giant of our solar system. What we learn there won't just tell us about Neptune, it will help us understand the countless ice giant exoplanets orbiting stars across the galaxy. In many ways, Neptune represents the final frontier of the solar system's planets. It sits at the edge of our neighborhood, guarding the gateway to the Kuiper Belt and the interstellar beyond. To study Neptune is to look outward, not just to the edge of our sun's reach, but toward the stars themselves. So, as we leave Neptune behind, let's remember, the universe is vast, and even in our own solar system, there are still oceans of mystery left to explore. Neptune stands as a symbol of those mysteries, a deep, blue giant, waiting for us to return.